Okay, so this is a program to illustrate the working of this TreeMap class in this java.util, which is a collections package. And TreeMap is basically a key value pair based data structure. So it stores the keys and the corresponding value. So they could be any data type, and it also stores the keys in ascending order. So even though you may add keys in some other order, so for example, if I add this and then try to add this, right now this is ascending, but if you want to add 23, it kind of gets inserted in between 10 and 20, 78. So it stores things in increasing order, ascending order, depending on how you can order the key values, the keys 10, 23, and 78 in this case. So now one thing you should also note is the tree map can have only unique keys, which means a key can appear only once in the tree map. So for example, I had these three key value pairs. So now I'm trying to say to insert a key and its corresponding value 63. If I try to insert this key value pair to the stream map, then basically you're going to replace or overwrite the value for that entry with that key 10, 63. So the previous value will be lost or overwritten basically. So when you try to insert an entry, a key value pair with where the key is already in the tree map, then it's that record for the key value pair which was there originally will be overwritten with the new key value pair. Okay, so that's what you have to remember. So let's go through this example. So what this example does is we are going to create an array of random number generators. We have uh, like several random number generators, each generating random integers between 0 to maxval minus 1. So each generates integers in the same range. Okay, so maxval is an input value that will be passed by the user, and each generator will generate this elements per gen, that many elements, and put as each generator generates those elements, we'll put everything together in one single vector. I call it as element vec, and then we'll iterate through the vector and find which integers basically that we generated randomly appear more than once. So what we'll do is we will, as every integer appears in this tree in the vector, we will update the number of occurrences, which is the frequency, in a tree map. So the tree map will have basically the integers that are in this vector, and comma, the value will be the number of times those integers appeared in that vector. Okay, so let's do that. So I input the number of generators, the random number generators we want, the maximum value that could be generated by each generator, and the number of elements that we could generate with each generator. So I'm creating now a random array. Okay, this is a class random. So I'm creating basically an array of random number generators. So this is the number of generators. Okay, and now this is just an array. So what you have to do is you have to instantiate each of those objects in this array of random number generators. So I have a for loop that goes from 0 to num generators minus 1. So basically that many generators. Now for each of them we are going to instantiate this object of class random, and we could pass the system time as the seed. But since all these programs are running pretty quickly, we don't want, and this is returning the current system time in milliseconds. So we don't want two random number generators to be instantiated with the same seed value. So what I do is I multiply the system time by this gennum plus 1. So gennum is starting with 0, so this will start with 1. So each of these random number generator objects have a unique gennum value. So the seed, which is basically the product of these two, will be also unique. Okay. Alright, so then we open inside another for loop where we essentially try to generate that many elements. We want each generator to be able to generate elements per gen, that many elements. So we generate each of them. So this is the way we generate the random numbers. So random gen of gen num is going to be basically referring to that particular random number generator object inside that array. So we have an array of random number generators, and this is that particular random number generator object. Dot next int max val is going to give you the is going to generate the random numbers between 0 and this 1 less than the maximum. Okay, and we store all of those elements in this element vec. Okay, and then we now have to populate this tree map. So what we do is essentially go through this vector. So index equals 0, index less than element vec dot size, index plus plus. Of course, I create an object of class TreeMap. So tm is the name of the object. It could be anything that you want to give. And then this is how I retrieve each element in the vector. So element vec dot get index is going to return that element, and of course when you put it, it will be inserted as an integer object, but when you retrieve it, it will first come out as an object of class object. There's always a superclass called object in Java. So you have to kind of typecast it to an object of class integer, which is a wrapper class for int, and then you have to do this int value thing to essentially extract the scalar int value from the wrapper class object integer. So this is now your element. Initialize your element count is to be 0, and check whether if that element is already in the tree map. So this is how we check, because you know this element is going to be a key, because this is like we are going to store the key, the integer values, and the number of times it appeared. So if this element is already in the tree map, so that's why tm.contains key means we are going to check whether that key is already in this tree map. So if that element is already there in the tree map, tm.contains key, a new integer of element, is going to return true. If it's not there in the tree map, it's going to return false, but in this, if it is there, it's going to return true. And we go inside the if statement, and this is again now extracting the value corresponding to that entry for that element. So if that is there, so what you can do is you can say get new integer of elements. So this way you can extract the value for the corresponding key element in this tree map. And again, when you extract something from this collections, you'll extract as an object of class object. So you have to typecast that to an integer wrapper class, and then call the dot int value to extract the scalar int. So that's going to essentially store the value for the number of times that element has already been as because you're traversing the vector, right? So how many times you already seen that element in that vector, that's the element count. Now if it is not there, you won't go inside the if statement, you won't execute this line. Only if that element is already there, you will execute this line. If it's not there, you will not execute. So your element count, if it's not there, if the element is not there, element count is already initialized to 0, then you can increment element count plus plus. Or if that element is not there, you will get the number of, or if the element or if the element is there, you will get the number of times that element appears in that vector. So if, say for example, it appears 5 times, element count will be 5. So when you come out of this if statement, because this is the if statement, it the block ends here. Okay, so when you come out of this statement, element count will be now 5. For example, if the integer appears 5 times, or it has been seen 5 times so far, now you increment that by one more value. So either from 0 increment to 1, or whatever be the number of times it has been seen so far, you increment that by 1. And then what you do is you do this put thing, which means you are putting back the key value pair, which is again the element integer key value, and the number of times it has appeared, which is the element count. So this is where in this example, as I said, for example, if integer 10 has appeared so far 63 times, when you try to put 10 comma 64 after incrementing the 63, which is element count, it's going to replace this. So this is very effective in a tree map. Okay, Of course, you can use this only for applications that can do things with unique keys, like what we are doing. So now what we want to do is we want to go through that tree map that we just set up, and try to find out which elements appear more than once. So essentially in this case, all these elements appear more than once. But if you have an element, for example, something like this, it appeared once, only once, then we don't pull up that integer. So we pull up only those integers that appear more than once. So now I'm going to show you one way that you can use to iterate through this tree map. So for example, this is a tree map of key value pairs using this set class and iterator. Basically the iterator, we can go through the L trees in the tree map. So what you should do is you call the entry set method on this tree map object that's going to return basically the key value pairs, put together everything as a set, and then you iterate through this set. So you call the iterator method of this set object and the class set, and that's going to return a reference to this iterator. So all these names, ITR or SCT, this SCT, you can give any name you want, but these are built-in classes, set and iterator. Okay, so now what you do is you are going through each of those elements in the set, which is basically key value pairs. So you're saying ITR has dot next of, which means if there is at least one more key value pair to go through, then you will extract. You'll go basically you're checking. You're checking whether there's at least one key value pair to extract. If so, you come inside the while loop and you try to extract by calling the next method of this iterator. And this map.entry is basically a class that stores those key values. Okay, so it extracts one key value pair essentially. So what you can do now is this map entry me, that's my name, me, you can give any name for your object. So me.getKey is going to return the key value. So again, it returns it as an object of class object. So you have to wrap it up. We know it's an integer object. So we wrap it up with the integer wrapper class and then call dot int value, that's going to get us the integer. Similarly, the get value, me.get value is going to return the value corresponding to that key as an object of class object, and then you wrap it up with integer, and then you call dot int value, that's going to be the value. So now you are essentially checking if that value is greater than 1, because remember all what we are storing here, the frequency of appearance of those integer keys. So if the value has appeared more than once, if value is greater than 1, what you're trying to do is in that vector elements more than once, you're trying to add that key. So this elements more than once is a vector that you are trying to populate now that basically has only integers that have appeared more than once. Okay, so we are going through this tree map entry by entry. So that's what this iterator does, one key value pair at a time, and you're checking whether the value that you have stored, which is essentially the frequency of appearance or the number of times that key has appeared in that original vector, and if you're checking it is greater than 1, you're adding that key to this elements more than once vector. And after you have gone through that key value, the pairs, which is essentially the tree map, then you can just print elements more than once and print the contents of the vector. Okay, so let me run it and see what happens. So I am compiling it, and I don't need to worry about the warning missing version 1.7 or something, and it could generate this warning for using some of the collections classes. That's fine. So I'm going to pass the program as compiled. So I'm going to now pass the 3 input arguments. The first argument is the number of generators you want. That is like we're using 10 generators now. And the second element is the maximum value that each generator can generate, and the third value is the number of elements you want per generator. So essentially what I'm doing here is I am using 10 random number generators, and each generator can generate a value of at most 100, and actually it will be 100 minus 1. The way you are passing, for example, you're passing here Maxwell, right? So the range, it will be 0 to 1 less than 100. Okay, so it will be 0 to 99. And then the third argument is going to be the, if you see the inputs, it's going to be the number of elements per generator. So each generator is going to generate 5 elements. Okay, so you're going to generate you're going to use 10 random number generators. Each can generate values from 0 to 1 less than 100, and each generator can generate 5 elements. Okay, so if you do that and find out which elements appear more than once, these are the elements. And you can notice here the elements that appear more than once are listed in this increasing order. The reason for that is the vector doesn't store things, it does not store things in a sorted order, but the elements or these elements more than once vector come from where? The tree map. And you're going through the tree map sequentially, and the way TreeMap stores elements are, it stores them in, like for example, if 45 is supposed to be stored like this, I'm sorry, so it's supposed to store like this in a sorted order. So that's why it pulls out things also in this increasing order of the key values, and as it pulls out them and finds if it's more than if it occurs more than once, it puts them in the elements more than once vector. So in the vector basically stores things in the order in which things are added. So if you add things out of order, like vectors only single dimension, okay, remember. So if you add things out of order, it is going to store it in this order. It's not going to sort it for you. But on the other hand, the tree map, which is a two-dimensional data structure that uses key value pairs, even though you may be inserting the keys in out of order, as you insert them, the tree map is going to rearrange them and store it in the sorted order of the keys. Okay, so we'll stop with this.